This activity called Back to the Post has some graphs that we saw before. Each graph represents the distance the dog is from the post, and it's measured in feet, and then time is in seconds. So again, on the x-axis we have time, and remember these are our inputs to the function. And on the y-axis we have the distance, which is in feet. And that is our output, or our dependent variable. So now we're going to go through and look at some of the questions. So question 1, how far away was a dog from the post 60 seconds after the owner left? So what I'm going to do is just record here. We're looking at day 1, day 2, and day 3. And we're looking at an input of 60 seconds. What would the output be? So the day 1 graph, as I go for the input of 60 seconds, the output is 4 feet. So now at day 2, at 60 seconds, the dog still is 4 feet away. And here at day 3, if the input is 60 seconds, the dog again is 4 feet away. So I'm going to go back and just put that on my paper. We have day 1, 4 feet for all of them. So now, how far away was the dog from the post when the owner left? Well, when the owner left, that's at 0 seconds. So here, we're looking at an input of 0 seconds. And then we're going to go day 1, day 2, day 3. So at day 1, at 0 seconds, I'm going to estimate that that's about 1.5 feet. Day 2 at 0 seconds, 1.5. And day 3 is also at about 1.5 feet. So I'm going to go back to my paper and record that all of those are 1.5 feet. So now the owner returned 160 seconds after he left. How far was he? How far was a dog from the post at that time? So again, we go back and we look at the end for each day, how far was the dog from the post? So again, this is with the input of 160 seconds. We have to figure out, well, what's the output for all of those? So again, we have day 1, day 2, and day 3. So here, the output, I'm going to estimate that. If that's 3 and that's 4, I'm going to say maybe 3.8 feet. Day 2, that for sure is exactly at 160 seconds for the input. The output is at 4 feet. And day 3, if the input is 160, the output, that seems to be about a half of a foot. So for a half foot, I'm going to put 0.5 feet. I'm going to use decimals. You could also use the fraction 1/2. Either is fine. So we write 3.8 feet, 4 feet, and 0.5 feet. So now, how many seconds passed before the dog reached the farthest point it could reach from the post? So when the dog kind of ran to the end of the leash. So if I'm looking here, this is the farthest point for the dog. So for day one, it looked like the time would be about 50 seconds. And again, I'm writing about to say that I estimated. So day two looks like that is going to be between 20 and 40 seconds, but really kind of closer here. So I'm going to say about 35 seconds. And then day three, it looks like the dog ran right to the end of its leash right away. So that looked to be at about maybe 3 seconds. So I'm going to go ahead and write that on here. We have about 50 seconds, about 35 seconds, and about 3 seconds. So now it says, consider the statement the dog was 2 feet away from the post after 80 seconds. Do you agree? So we're going to have to go and look. After 80 seconds, it's close to 2 feet. Not on day one. Here, day two, 80 seconds, it's at 4 feet. But on day three, after 80 seconds, we're at exactly 2 feet. So if I look here, I would say on day three, this is true. So now, what was the distance of the dog from the post 100 seconds after the owner left? Well, that kind of depends. So 100 seconds for each day. We could say day one, it looks to be about, I don't know, 2.2 feet. So what I'm going to do is just kind of write day one, 2.2 feet, and then we're going to look at day two and day three. So here on day two at 100 seconds, it's at 4 feet. And day three, 100 seconds, looks to be about 1.4 feet. So here, 1.4 feet. And again, day two, that was at 4 feet. So again, to summarize, on the x-axis is the input of our function. And on the y-axis, if we're looking at graphs, is the output of our function. And to be a function, every input can only have one output. So what that would mean is our function has to pass a vertical line test, where a vertical line can only touch the function once.